Hey there! We are now moving on to aerodynamics, but first, let's take a moment to cover the basics of the three primary controls and what stability means. We'll start with the three principal axes around which an airplane rotates. First, we have the longitudinal axis, which runs from the nose to the tail. Next is the lateral axis, stretching between the wingtips. Finally, the vertical axis extends from the top of the aircraft to the belly. What makes flying so unique and thrilling? Perhaps it's the extra freedom it offers. While cars are stuck shuffling along their two-dimensional roads, airplanes get to party in three dimensions. An airplane rolls around its longitudinal axis, pitches about its lateral axis, and yaws about its vertical axis. As a result, these axes are also known as the roll axis, pitch axis, and yaw axis, respectively. The point where the three axes intersect is the center of gravity, CG. This point serves as the ultimate pivot around which the airplane rotates, whether it rolls, pitches, or yaws. An aircraft remains perfectly balanced when suspended at the CG. Keep in mind that the CG is where gravity acts on the aircraft, and it can shift if the weight distribution of the airplane changes. CG plays a crucial role in aerodynamics and significantly affects how airplanes behave in the air. The controlling surface for rolling is the ailerons. Typically, they work in sync, with the left and right ailerons moving in opposite directions, one going up and the other going down. A key design feature that affects control characteristics is stability. We will explore it in greater detail later. For now, just know that stability is the plane's ability to resist deflections, which can happen due to things like pilot inputs or external factors like turbulence that mess with the plane's current attitude. When the airplane rolls, it rotates around its longitudinal axis. But the direction of the rotation is sideways, as though the lateral axis is sweeping around the longitudinal axis. Since the axis of rotation is perpendicular to the direction of rotation, roll stability is often called lateral stability. Now, let's turn our attention back to the primary flight controls. The elevator, or in some aircraft designs, the stabilator, is the control surface responsible for pitch. By moving the yoke backward or forward, the pilot adjusts the elevator to rise or lower the aircraft's nose. As the airplane pitches up and down, it rotates about its lateral axis, with the movement occurring along the lengthwise direction. Once again, the rotation axis and direction are perpendicular to each other. Therefore, pitch stability is also known as longitudinal stability. When it comes to yawing, the rudder is your guy. The pilot uses the rudder pedals to control the rudder and steer the aircraft's nose left or right, both on the ground and in the air. As the airplane yaws about the vertical axis, it sweeps across the entire horizontal surface. Thus, yaw stability is often referred to as directional stability. Stability plays a crucial role in defining the characteristics of flight controls. There are two basic types of stability: static and dynamic. Static stability refers to the aircraft's immediate response to disturbance. If the airplane naturally tends to return to its original position, it is considered to have positive static stability. Dynamic stability, on the other hand, describes the aircraft's response over time. Positive dynamic stability typically involves a damping effect, where the airplane, when disturbed, may overshoot its equilibrium and oscillate before settling back. An airplane exhibits neutral static stability when it remains in a new position after a disturbance. Neutral dynamic stability, however, tends to keep the aircraft from settling, resulting in continuous oscillations around the equilibrium point. Negative stability means the airplane is unstable and will deviate further from its original position, even after the disturbing force is removed. It's important to note that an airplane's static stability and dynamic stability don't always align. An aircraft can have positive static stability but still be dynamically unstable, as oscillations following its initial attempt to return may overshoot or undershoot asymmetrically, preventing it from stabilizing. That's about it for today. Next time, we'll dive into aerodynamics. Stay tuned.